painted all the same color.
I don't. This one's different.
She has never once painted an entire hand the same color.
Yeah.
Ever. I've never seen it.
But you did today.
No, I didn't.
No, I
It is
just saw
look the
her.
same. This is light pink and that's silver.
Accent Neo.
Her hands aren't even the same color. These are like purple and these are silver.
Kinda like normal. Outside the box.
I have to take it off for my audition. It's too abstract.
Are you not supposed to have anything else?
Well, it's not professional.
Are you guys still talking about your hair? It's kind of sad.
Wait, I don't do other videos.
Did you
I
see
did
that?
today in history.
Oh, Lord.
No, I don't.
And you do it in lit too, like you just read, like you read when we're discussing.
Oh yeah, that's true.
Oh, yeah, that's true.
I'll just let that record.
Did you see that we don't have the
Who are you sitting for?
That's
I can't afford
what
it.
she plays with her hair. What?
No, but he's
It's
not
not-
sick
it's not
because he
functioning,
came in
so we're
yesterday and he was
testing it out to see what's
fine.
going on.
Clearly, he's just covering
I
Plus,
just-
I like to think
I
it's
know.
functioning.
Well,
Because we don't have
especially
like
new.
because they don't have class today either.
I hate when that happens.
I
I walked around the entire day and told you this. I hate it when you have like text on your shirt and no one just lets you know.
And like it feels wild here.
And then you're
Or like
you're like
lower the layers.
yeah.
Has to be
Okay,
on the
so
scale.
adding it out your notes, please.
I like your outfit today.
Me too. Okay, so we've talked about the four kinematic equations, and we've also talked about free fall in the past and how there's special characteristics that are involved when something is free falling. So a lot of this is just putting two and two together. So when we are using kinematic equations with free fall, there's some things that they wouldn't necessarily need to tell us that we should know. So if they say it's a free falling object, then we know that the acceleration is what? Does anyone remember?
9.8.
Yes, and I'm going to say negative 9.8 meters per second, or meters per second squared. So that's for any free falling object, the acceleration will be negative 9.8. So if they tell you it's free falling, we know the acceleration, they wouldn't necessarily have to say that. If it is simply dropped, so it's not thrown, the initial velocity, and if you want to say v sub I, you can. Initial velocity is 0. Which we've talked about other situations. A lot of times we, based on the problem, we can say that the initial velocity of the object was 0. That would be the same if we're having a free falling object that's high up and then we just drop it. If it is projected upward perfectly vertically, then we know that the velocity at its peak is 0. So if it's going straight up, like think about a rocket, and then it's coming down, when it's at the peak, it's going to have a 0 velocity. We also know that the velocity when it's projected is equal in magnitude, meaning the number of the velocity will be the same, the opposite in direction when it returns to the same height. So it might be helpful to draw a picture for this. So if the object is going straight, we're not gonna be able to show it straight up and straight down, but if it's going straight up and straight down, then the velocity at its peak up here, the velocity is 0. And the second part that it's saying is that whatever its velocity is, say here, when it's projected, it will be equal to its velocity here, except for it will have a different sign. So like if we say that this velocity is x, for example, then the velocity at this point would be negative x. And that would be true for any point on the graph when it's at the same height. Questions about that? Okay, so let's do an example. Here's another creative name, I guess. Luke out below drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. So we're going to use kinematic equations for this, so we need to figure out which variables that we know.
The height or the distance c is from the ground.
Okay, good, so that's D. So the distance is 8.52 meters.
Initial velocity is 0.
Good. Initial velocity is 0.
Acceleration is
Good. Acceleration is negative 9.8. And we're actually going to call the distance negative as well, since it's up. It's starting at 8.52 and it's going down. So we're going to call that negative 8.52 meters. And so we have 3 that we know, and what are we trying to find?
Time.
Time. Okay, so go ahead and look at your equations. Which one is going to be appropriate here?
Or like the initial velocity times time plus half times acceleration times speed.
Yes, the distance equals the initial velocity times time plus 1/2 the acceleration times the time squared. Okay, and then we'll substitute in what we know. So the distance is negative 8.52. Initial velocity is 0. We don't know what the time is. Plus, we'll call it 0.5 times negative 9.8 times t squared. negative 8.52 equals, that will drop out. And what do we have there?
Negative 4.9 times squared.
Okay, good. And what would we do next to solve for t? Divide by negative 4.9. So times squared is 1.7. Okay, and remember, try not to round that until the end. So there's one more thing we have to do to get t by itself. Right. So t is
Can we keep it as squared, or do you want the decimal next?
the decimal, please. Okay, good. So if you round to the near, they don't tell you how to round, but if you round to the nearest hundredth, that would be 1.32. So it would take 1.32 seconds. And if you, when you were working out this problem, you didn't make the distance negative 8.2, and you came out with a negative time, then you could probably ask yourself, why is my time negative, and what do I need to do to fix it, and maybe that would lead you to think that maybe the distance would be negative. Because really D, we say distance, but what would be a more accurate term for that? That starts with D. Displacement, right, which takes into account the direction. Okay, questions? Any of you guys start the calculator pad questions? What did you think about those?
They're slightly confusing. I like following with the audio. That really helps me, but when I'm looking at it on my own, I have trouble, but I can follow well with the audio.
See, the audio didn't work out here, so I didn't get to see it.
It worked on my home computer. I thought it got, like, the first part was a little hard, and then it got easier, so I started to get it better.
Okay.
Yes, I don't know.
Good, yeah, I like that they have that so that as you're working through it, you can get help as you go instead of waiting for class to have all your questions answered. Okay, we're gonna just do some practice questions right now. If you guys want to get a whiteboard and a marker and an eraser.
These are my favorite.
Oh gosh, how am I still
Yeah, thanks for the help.
stuff? I got you, you're worried about You showed me. Actually,
Can you pass that to us?
oh, oops, I know.
Well, you're gonna need a marker.
I have my own marker.
Buy your own marker. Oh, that's nice.
Maybe try the back. This must be
Huh?
Oh, yeah, did you take it?
Okay,
No.
an airplane accelerates down a runway, and this is not just the free falling ones, this is all of what we've done so far. An airplane accelerates down a runway at 4.10 meters per second squared for 18.9 seconds until, that should say it, finally lifts off the ground. Determine the distance traveled before takeoff. Okay, so list the information that you know. Yeah. Okay, so you should have that the acceleration is 4.10 meters per second squared. Time was 18.9 seconds. The initial velocity would be 0 meters per second, and our unknown quantity is distance. So if you look in your notes at your 4 equations, pick the equation that would have those 4 variables in it.
Do you have an extra calculator?
Yeah, you guys can use these whenever. They're just basic.
Thank you. Marnie, it's always the smallest little calculator.
Probably, but yeah, it's like the same size.
They're so cute.
So make sure you have the right equation. That would be the equation that you need. Did everybody get that? I think you guys all did.
Actually, can I have a calculator as well?
I had to remember to.
Oh, was that the same thing?
0.5 times.
Well,
Do you have the
well,
method?
think about if it makes sense for the question. What are we talking about in this question?
An airplane.
An airplane and how much
This is gonna be long.
space it needs to take off. So it is always good to think about your answer and if it makes sense for the context of the question.
Can you not say the answer?
Yes, I shall. I will wait.
I'm gonna erase it.
Okay, is everybody ready? I think you all got it. Looking at your boards, you should have 732 meters.
I know, I was thinking the same thing.
Okay. A car starts from rest and accelerates uniformly over a time of 5.42 seconds for a distance of 130 meters. Determine the acceleration of the car.
Are we going to have to memorize our kinematic equations?
No.
Yes,
Cool.
thank you.
Will they like be on the top of our test paper or something?
Yes, I'll somehow give them to you, or write them on the board or something.
Does uniformly mean constantly?
Yes, but it's constantly accelerating. So it's not saying that the velocity is constant,
Oh.
but it's telling you that the acceleration is the same.
Ew, like my hair on it.
Oh.
That's lovely. So do you get VT and D? And then you'll pick right?
Yes.
I know, like yo-yo. Is acceleration the second square?
Yes. You guys are doing good.
I wonder if I did that.
That was loud.
Sorry.
So
Not.
I was like,
My piece of paper generally was dragged through, but apparently I can hold it together and the dryer is bored. I know. I think I ran out of space on the piece of paper, so I'm like, oh, this little corner will work. And then I like wrote two different sides of paper.
wait,
Oh,
circle it.
Yep.
Like, here's my answer for this number. Great.
Oh, circle.
But you know when you have like an answer and an answer and that.
Circle plus a circle is not equal to square.
I like your little object. Good. 8.8, I think all of you guys had
I
that.
got 8.9.
I rounded
It just depends on how you round it, yeah, they don't, well,
So we're not
we
doing
really
sig
should talk about sig figs.
No, 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 no.
no.
We have such bad memories. Like the first, like our first test.
Oh my
had to,
god.
like,
That was
give us
awful.
all of our points back because like no one.
No one
We
got
got
it.
like lectured and we all like
Like,
cried.
I cried.
It was really bad.
It was awful.
For right now, we're not gonna talk, we won't do sig
I think
figs,
it started to make sense later on. Like
And
after
then,
he
yeah.
then he
explained
said
it,
that it
but-
wasn't really like that important
Yeah.
anyways,
I
so
don't
we
remember
felt
him
like
saying.
he didn't need to like go over
He was just
that,
kinda like,
which I don't know.
and it's okay, whatever.
Well, he had us do it on the final though, didn't he? So it had to be kind of important.
Yeah.
No, he did he? I don't
No,
think
he
he
didn't.
did. No,
No, he didn't.
No,
Otherwise, I would have been
I'll
freaking
have to
out.
think about college level.
I'd rather know it now
sig
than
figs,
asking
yeah.
a college
Yeah,
professor
yeah.
how to do it.
Yeah, we should probably talk about it. It's really not as bad, and especially if you've already like, you have some background of it, it will become
Maybe that will
easier.
help, yeah.
Okay, a feather is dropped on the moon from a height of 1.25 meters. The acceleration of gravity on the moon is 1.67 meters per second squared. Determine the time for the feather to fall to the surface.
Is that your distance, the height?
No.
Yes.
No.
And your initial velocity index is
Yes.
usually is that what you usually should test?
Yeah, if you're not already moving, yes. it will.
Is that your phone?
Probably.
No. That's really loud.
It all depends on how I sit it in my bag.
Yeah.
What'd you get? It's Monday. Today.
Yeah.
Oh, yeah. Until we walk out of the classroom.
It's usually how it is. Yeah, it makes sense right now.
That's so August.
And I'm not doing anything to help you.
I know, I don't
You
know
guys are
why.
just laying it all
Yeah, I don't know
around.
how we're doing
think
this.
it's
I
the
don't know how we're
whiteboard.
doing
It's
it,
the
but
whiteboard.
It's the whiteboard.
You use these on the tests.
It's the classroom.
The
So
only
they walk
way.
out of the classroom like, what? It's kind of know anything.
You're like, what's acceleration? What's the answer? Sorry.
Victory.
Yay!
1.22.
So whenever we first started doing this, I was so confused. Now we understand it.
Good. Very good.
Those are beads.
And this, here's another airport one. In December designing an airport runway, an engineer must ensure that it is long enough to accommodate a plane with an acceleration of 3.2 meters per second squared and a takeoff speed of 68 meters per second. What is the minimum allowed length for the runway?
So the speed,
The takeoff speed
that
means
your
what?
that'd be like your
It's the
final.
final velocity.
Yes, that's like when it's lifting off the ground.
Or what it starts at is 0, because
Yes.
it's just sitting there.
Right.
You have to erase your phone.
It's almost like you're making that noise.
I got
No, that's not.
Rounded. They said rounded, it's rounded, they rounded it.
Oh,
from-
that's the answer.
Because of
Safe.
safe things.
The
So
draw.
my answer was.
I won't do those unless I necessarily have to. But I feel like we should do that.
We will, just not, just not yet. We will though. Cause I think it would be good for you guys.
Just because I was looking at the psych requirements, like to get like a BA and a BS, and you have to take like chemistry and like.
Definitely, yeah,
Oh,
definitely,
it's not 6.8.
it's used
Not
a lot
looking
in
for it.
forestry. Okay, I think we have time for at least one more. Okay, a bullet travels